So there's always a lot of emphasis on absolute value equations and inequalities. How do you solve them? Remember, in every case, if it's not isolated on one side, isolate it first, right? You got to do just like solving an equation for x. You got to take away everything that's with it until that absolute value is by itself on one side. And then we have 3 different steps to finish the problem, right? It depends whether it's an equation, a less than, or a greater than. 3 different processes. What you don't do is you don't, for example, take away 3 here and here when you still have absolute value symbols. Right? You never do the algebra when you still have the absolute value symbols. The first step at this point is break down the absolute value. In the case of an equation, you're going to write 2 equations. One will be x. One will be that x plus 3 equals 9. Because if it does, what's the effect of the absolute value? It's nothing, right? Because it's already a positive 9. It equals positive 9. The other equation that you solve is x plus 3 equals negative 9, right? Because if it does, what happens when you apply the absolute value? Changes it to a positive, and so it's equal. So you solve 2 equations. Here's one, x equals 6, and this one, x equals negative 12. Right. Now, for an absolute value less than, what you do is you make a 3-part inequality. All right, a 3-part inequality looks like this. Negative 9, because that's positive 9 on the right, negative 9 goes on the left. X plus 3 less than 9. What it means is this expression, the value of the expression has to be between negative 9 and 9. It could be negative 8, negative 7, any decimal or fraction in that area is fine. It just can't be less than negative 9 or greater than positive 9. It's in between these 2. Now, we're going to see when we do this one, because it's a greater than, that we use 2 different inequalities. X plus 3 greater than or equal to 9, or x plus 3 less than or equal to negative 9. A lot of times you try to do that here, and you can get it right? You could be correct if you wrote down x plus 3 is less than 9, and negative 9 is less than x plus 3. Those 2 together would be the same thing as this 3-part inequality. And on the test we do in this class, you sometimes did it and got it right, and that was fine. But you'll never see that on one of these tests that are being given by somebody else, because that's not the way you deal with a less than. You make it into a 3-part inequality, and then you solve for the variable in the middle. In this case, because there's a 3 in the middle, a plus 3, you subtract 3. But because it's 3 parts, you subtract it 3 times. Right, so now it says the value of x is in between negative 12 and 6. That's what a 3-part inequality is. And if we graphed it, it would look like negative 12 on the left, 6 on the right. It would be open circle on both because that's a less than and not less than or equal to. And the shading, again, is in between the negative 12 and the 6. If I solve this one, I would solve both of these separately. So I subtract 3. X is greater than or equal to 6. Or x is less than or equal to negative 12. All right, there's my negative 12. There's my 6. And it's closed circle now because it is or equal to. And it's shaded to the left and shaded to the right. So notice the pattern. When you get a less than, it always looks like this. And on the multiple choice kind of test, there'll be 2 out of the 4 are going to be the wrong pattern, right? So you can just discard them. The greater than always looks like this, right? Where it's the ends of the number line are covered, but the middle is not. Okay.